Hello. Today we're going to talk about, I'm going to call that another look at electric potential and electric potential energy. So the way we want to look at it is, let's look at the mass first. So when you have a mass and you are in a G field, so the natural tendency, right? The tendency, if you just let go of a mass in a G field, it will go this way. So when it goes this way, what's happening? It's reducing the potential energy here is high. And the potential energy here is low. Okay, so that's the tendency. You go from high potential energy to low potential energy. Okay. Now, if we take a look at, let's say if we have two charges, positive and positive. Let's say this charge is it's not like, it's just in free space, right? In free space, and the gravity influence obviously is very small. And now, if you just put these two charges, you don't secure them in any way, then the natural tendency is that these two will repel each other and they would try to move away from each other, right? So that's how they would do, right? So what happened then is your R has increased, right? And let's take a look at the potential energy form for electric, right? So that's U is equal to K. So we're going to call this one Q1 and Q2, right? So Q1, Q2 divided by R, right? So after some time, this is going to be increasing, right? So R is increasing. And this doesn't change. So you know when R increases, the U will go down, right? You can see we are going from high potential energy. So this is high, right? High potential energy to low potential energy. Okay? So there is some analogy here. And now let's take a look at another example here. So if I have a positive and a negative, right? So it's called like Q1 and Q2. And now if you just put them here in the free space and you don't secure them, then they will naturally try to attract each other and they will go this way, right? So you can see the R prime is less than R, right? So this is R. So the potential energy is equal to, right? Equal to K Q1 Q2, okay? Divided by R. But keep in mind, this is negative. So you got to put negative number here. So you're going to be negative there, right? So we know on the top here, it's going to be negative, okay? So as R is going to become smaller, right? So it's tend to go smaller from here to here. So R is going to go smaller. Because this is smaller, that's negative, right? So it's going to become more negative, right? So it's going to become more negative, right? So for example, you go from -1, and that's negative sign, and this is smaller, right? Smaller, that's a bigger number, but more negative. So become -10, for example, right? So again, this is going from high potential energy, right, to low potential energy. Okay, so that's the natural tendency for charges and for mass, right? So it's go from high potential energy, right, to low potential energy, right? Okay, so this is natural tendency, right? Okay, now let's take a look at the potential, right? So we're going to look at potential now. Now let's say if we have this. So that's a charge. And around here, we have potential, right? And potential in this point is K, let's call this one Q. KQ divided by R, right? So this is R, okay? And if I put a positive charge there, okay, right? So this is just the potential, right, at that position. But now if I put a charge there, call this one, I'm going to call this one. So that's Q1 here, Q1. I put a Q2 there. What would happen, right? So for the positive charge, right? For a positive charge, okay, the natural tendency is that in the field, he like to go from, so this compared to here, KQ1 divided by R prime, right? So this is R prime here, okay? So this is high potential, this is low potential, right? This position compared to that position, this is high potential, right? So this is high potential, high V here, and this is low V here, right? So you can see for positive charge, he like to go from high potential to low potential, okay? Now let's take a look at the negative charge now, okay? So if we have here, again, a positive charge here, call that Q1, right? So we have this one here, right? So that position, we know so this is R prime again. So this V prime is equal to K Q1 divided by R prime, right? So this is V prime is less than V, right? So here is V. V is equal to K Q1 divided by R, right? Here is R, right? So this is smaller, so that's bigger, right? So this is high potential again, high V, and this is low V, right? Okay, now if I put a negative charge there, and because at this field, she would like to go, well, he would like to go this way, right? You can see for negative charge, like to go from the natural tendency, like to go from low V to high V. Okay, so that's kind of important to keep in mind. What's the natural tendency? So I call that another look, right? So what we did is another look at PE and potential, right? Electric potential. So well, no matter mass or charges, positive or negative, right? The natural tendency is to go from PE high to PE low. Okay. But for the V, for the positive charge, right? The positive charge like to go from high V to low V. Okay. But for negative charge, you like to go from low V, right, to high V. This is the natural tendency. Okay. All right. So that's all we have. See you next time. Bye-bye.